All right, so I'm recording now, and we are going to figure out how to get 0 on this problem. So let's go ahead and start a new whiteboard, and go ahead and read that off to me, Carly.
Okay. The limit as x goes to infinity of x minus 5 over 7x squared plus 10x.
All right, so we're going to do this the long way to prove that it's true, and then we'll
Okay.
do it, and then we'll do it the shorter way that just gets us straight to the answer.
Okay.
So you may remember with one of the other problems that we've done that was kind of like this, what we want
Mm,
to do is find the highest degree of the denominator. So what's
yeah,
the highest degree we've got?
the x squared.
X squared. So what I'm going to do is multiply the top and the bottom by its reciprocal. So it's going to be 1 over
Okay.
x squared on the
X
top and the bottom.
7 x squared plus 10 x times 1 over, wait, why 1 over x squared?
Because the x
Oh, because the
squared
x squared's on the bottom. Okay.
is the highest degree of the denominator. Yep. So it's based on, just to kind of make this a little easier to, oops, I don't want that color. Let me use like maybe yellow.
Oh wait, where are my colors? Oh, I laid them out before I left. Okay. Oh, and my teacher said that I could use colors on the exam as long as I didn't use red or anything that resembled red. Closely
Perfect.
because well, for obvious reasons, grading.
Of course. Of course. Yeah. All right. So x squared is the highest degree. And so that is the reciprocal that we're going to use. We're going to multiply by 1 over x squared.
Okay.
And then, and then what that does for us is as we distribute this into each of those terms, that's going to give us 1 over x when it simplifies because we have an x on the top and an x squared. And then this is going to be minus 5 over x squared on the
I'm
top.
confused where got the 1 over x.
So this was x over 1, right? Let's do this off to the side.
Okay.
So we have x over 1. Let's turn that into a fraction. And we're going to multiply this by 1 over x squared.
Ah, but you get x over x squared, which simplifies to just being x.
Exactly. Exactly. So that's going to simplify to be 1 over x because it's bottom heavy, right? The denominator has the higher degree.
I see. Okay. Now I see where you got it from. Okay.
All right. And then we're going to take this 1 over x squared and we're going to distribute this to each of these as well.
Okay, I'm gonna ask another stupid question. How did you get the negative five? Okay, I guess I just have to do it on the side again. Okay. The negative 5 over 1 times 1 over x squared. So you get negative 5 over x squared, clearly. Okay, it's so like, it looks so obvious when you do it to the side, but when you just jump there,
No, well, and that's good because everyone who's learning at this level is going to have similar questions, right? So
yeah.
if you've done it for 10 years, 20 years, then you just sort of take it for granted like I've been doing, right? But if you're seeing this for the first time, it is really important to ask those questions.
Okay, cool.
Which is why I think there's actually probably more value in this kind of content than there is when I just do it by myself. Because
Yeah.
like if I do my tutorials, I'm like, oh, you just do this and zip, we're here. You know?
Right. And I'm like, wait, what?
Right. Yeah, but when you're asking me each to back up each of those questions, I think that does tend to show
Okay.
where the trouble spots are.
Because
So
sometimes I feel like stupid asking because I'm like, I don't like it must be obvious and I'm just not seeing it. Well, and then it is obvious once I like do the work.
sure, yeah. Well, everything is not obvious until it is, right? That's
Yeah.
just the way. That's just the nature of questions, right? So Yeah, that's totally fine. But I can guarantee you that anybody who's watching this, all 10 people that are going to be watching this are they're going to also have some of the same questions, and that's why they're watching it. So
Okay, cool.
yeah, absolutely.
Okay,
All right,
then
so yeah, let's do. So we have 7x squared now, and we're multiplying that. We could turn this into 7x squared over 1 and
okay,
10x over 1 also.
times 1 over x squared. Okay, so that gives us 7x squared over x squared, which is really 7 over 1, right?
7 over 1, and 7x squared over 1 is multiplied by 1 over x squared. Let's do that off to the side.
Don't
So
the
that's
x squareds cancel?
it's 7x squared over 1, and then the x squareds will cancel. Yeah. So this
So
is
then I
gonna
just get 7?
so it's just gonna be 7. Yeah, these cancel out, and then the end result is just a 7.
Okay. So then I get 7. Okay, and then 10x over 1 times 1 over x squared gives me 10x over x squared, which say like 1x squared. So like I can't, you wouldn't cancel anything there?
No, you could cancel the x and one of those x's on the
So
bottom.
it's just 10 over x.
That's what I get. Yes.
Okay.
All right. Now remember that this is the limit as x approaches infinity. So
Yeah.
as the denominators, because now before it was a little ambiguous what was going on, but now we can really see this much more clearly because all of the x's are in denominators. And so when you have a constant on the top and you have a denominator that's going to infinity, what's 1 over infinity?
Um, I don't think it's 1 over infinity.
But what does it simplify to?
I really don't know. I didn't think you could simplify that.
Well, so let's see if we can spot a pattern. So I'm going to put like here in the margin, let me make a little bit of room. So what I'm going to do is just have you calculate what's 1 over 10.
Um, I don't know how to go backwards, like to
You
just,
can you can use your calculator for that.
okay. On 1 over 10. It, oh, mine just goes to 1 over, it just says 1 over 10 equals 1 over 10.
So it should be a um yeah, we're going to have to make that so that it can do an approximation.
Okay.
Or you could even use your phone calculator if you want to.
Or I could just say, wait, what's 1 divided by 10? Is okay, so if I have to just say like I 1 division sign it, not fraction.
Oh, yeah, exactly. You want the
Oh, okay.
you want
I
the
was
divide
putting
by
it
sign.
like
Yeah. Yeah.
I was
So it's
doing actually over 10.
but it's 0.1, right? Or
Yeah.
0.1.
Uh-huh.
And then if you've got 1 over 100,
1 divided by 100, 0.01.
and let's do 1 over 1,000.
1 divided by 1,000 equals 0.001.
So what pattern do we see emerging as the denominator of a fraction gets larger?
We get more zeros. Like the
We get
number,
more zeros? It gets smaller, and what's the smallest it could ever get?
oh, 1 over infinity. Just like infinity zeros. And then
Exactly.
I see. That's why it's 0.
That's why it's 0.
That makes so much more sense. Okay.
So what happens is that all of these zero out. This zeros out, this zeros out, this zeros out because they all have a 0 as the result when you have infinity in the denominator.
Oh, because They're all over.
They're all a
Okay.
constant divided by infinity.
Okay, but what about the 7?
So the 7 does not cancel out, which means that we do
So
not have an undefined. So
okay, let me
let's say,
circle these.
mhm.
Yeah. And say that everything circled is, you said, a one, like a constant over infinity.
That's right. Yeah, all of those are a constant divided by infinity.
Divided by infinity. Okay. Um, but that 7,
So we've got 0 on the top because it's 0 minus 0. And then on the bottom, we've got a 7 plus 0. So what is 7 plus 0?
um, 7.
Just 7. So let's get rid of that. So, and what is 0 divided by 7?
Um, oh, wait. 0 divided by 7. Oh, 0. Oh, okay.
So that is why this is 0.
Okay. So anything like the 1 over the infinity, it cancels.
So
Like
let's go
that
back up to the
goes
original.
away.
Yeah, so I'm going to go back up here to the original.
But that's what's
And
happening, is those are canceling. So like I can write in my notes the 1 over, like the constant over the x
mhm,
canceling. Okay.
yep. And so going back to what we originally started with, the very, very beginning, this was x minus 5 divided by 7x squared plus 10x. So only the leading terms of the numerator and the denominator matter. So this minus 5 is irrelevant. This 10x is irrelevant. And we know that that's going to happen when they zero out.
Right. Because a
So
constant divided by infinity is 0.
that's right.
Any constant divided by infinity equals 0?
That's right.
Okay. So they just disappear, is
They
what's going
disappear.
on. Okay.
Even if it was a billion. I mean, it's when we have 5 over infinity, sure,
Right.
that goes out to 0. But even if it was a billion, it doesn't matter because infinity is so much bigger than a billion.
Yeah. Okay, cool.
Mhm.
I get it now. That makes so much more sense. Okay, I would not have come to that conclusion on my own.
That's what tutoring is for. That's
Yeah.
how we get there.
Okay. I understand limits now. I feel like I
Cool.
really understand limits.
Awesome. Awesome. All right. What are
And
some other
hopefully,
things that we have to do for this test?
um, well, we haven't even touched. Okay, wait. We got to, I gotta go back in my notes. We were on question 5, and question 5 got really scary. Like the, like I don't know that I could do those on my own.
So
Okay. The
I'm
5, 6, and the 7s. I don't even know. 8, 9. There's so much. But
sorry.
it's okay.
Um yeah, so I do remember we were doing 5. It did get a bit crazy.
Yeah.
Was it C that we did?
We did, yeah, see. But then we figured out, like, as we got down to it, like, that we really didn't have to cancel, like, do as much work
Yeah, yeah.
with it.
So the part that was really bad, you didn't even have to do. So it was okay.
Yeah. I just have to put it in U prime, V prime, U, or U prime, V, V prime, U form. And
Mm.
then that was it, I think. And then cancel it a little bit. Ugh. I honestly, I don't even know where to start.
let's do maybe let's do D. Do you want to try that one?
Okay. 5D.
Yeah, 5D. I think we can get our arms around this one.
Okay. I'm just like, Jesse, I'm so scared. Because like if I saw this, okay, if I saw it, I wouldn't have my notes, which is the problem. But I would know it's a something times a something,
Mm-hmm.
but I wouldn't remember what it something times something was. Oh, product. Okay, I see it now. Something times something product. Okay. So this D is product.
Mm-hmm.
Okay. Wait, let me write it down. I'm getting ahead of myself. D over dx, x squared, minus 5x minus 1 to the fourth power. Okay. Let me try and figure out what I'm gonna do. Okay.
Yes, yes.
Um, product. Mm, is u prime v prime u. But if I remember correctly, oh, I skipped pages in my book. That's not good. Okay. Um, we need to no, we can't just take u and v from what we have, can we?
So we could declare that this is U and that
Okay.
this is V.
Where are my pens? Okay. Um, maybe I should use different colors now. Okay. Um, oh, you're doing blue as you? Okay.
Well, I could stick with what you do.
Okay. Yeah, I can do blue as you and red as V.
Mm-hmm.
Okay. So the rule is u prime. So we need to find, okay. Let me really think about this. We need u and we need u prime. So u is x squared minus 4. We got that.
Mm-hmm.
U prime in terms of x is um uh, oh 2x, just 2x.
Just 2x. Good.
Okay, that's not that bad. Okay, now we need to look at the mess that we have for v. This is what I have to do. I just have to like talk myself through it, I think, in the test because I'm gonna see it and I'm gonna freak out.
Right.
And I need to just be very calm. Okay.
Mm-hmm.
Um, V equals, we have to keep it with the 4 thing.
Yes. Good.
Okay. So V prime. I'm looking at this and I'm seeing this and I'm thinking, chain rule. Do we have to
Good.
use the chain rule on this?
That's right.
Okay, let me write that in my notes because I'm gonna study my ass off tomorrow.
Mm-hmm.
Okay, but I need to be very clear on my notes. Okay, so we're using the chain rule on this part. Okay. And chain rule is okay. I can figure this out. Um, uh, oh, we bring the 4 in front. We bring the 4 down in front. So it's 4 times 5x minus 1. And then derivative of 5x minus 1. Is that what it is?
And
Oh no, to the 3.
mm-hmm.
And then derivative of 5x minus 1.
And then derivative.
Okay. Um, it's just 5x.
What's the
Five.
derivative of
Five.
5x? 5. Good.
I'm gonna be okay. I'm gonna have to practice this a lot tomorrow.
And and like you said, take your time and talk yourself through it because you
Yeah,
do know this stuff. You do know
I
this
know.
stuff.
It's
And
in
it'll
there
look
deep inside, and I honestly think
yeah.
when I got sick, I lost some brain cells because I'm having like the hardest time with my memory
Okay.
lately. I don't know if it's like affected, if that's even like scientifically correct, but I've
Well,
just
yeah, sleep you probably haven't been getting in as much rest as you
I've been
need.
getting 8 to 9 hour or I've been getting 8 to 12 hours of sleep every night to try and catch up.
Okay.
But I still probably when you miss 3 days of sleep, you really can't get it back.
Yeah, I mean, you'll balance back out, but it'll take a little while.
Yeah. My brain's just still not completely there.
Yeah. It'll
Okay.
it'll get there. It'll get there. It's a little foggy now, but it'll get there.
So now it's a constant, the rule that we're about to use,
Hmm.
without looking at my notes, is it's um a u because it can be u prime times v
Hmm.
or v prime times u first.
Hmm.
It doesn't matter. Okay. So u prime, write this in colors. U prime. I can't believe I'm doing this on my own. Okay, kind of. U prime
Hmm.
um times r v. Okay. And then plus. Yes? No.
Hmm.
Yes.
It's plus. It's
Okay.
plus. Yeah.
Okay. Plus v prime times u. Yes. Okay. Okay. This isn't going to be pretty.
Hmm.
Um, so our u prime is 2x. So we have 2x um and then times our v, which is 5x minus 1 to the 4. Okay. And then plus v prime, which we said was 4 times 5x minus 1 to the third times 5. And then times our u, which is parentheses x squared minus 4. Okay, that's a lot of stuff. Um, but it's okay. So I think, can I evaluate this one side of the plus, like the uh left side of the plus before I even deal with the other side? Can I just,
Probably I would leave it right here.
you would, okay.
Yeah. Yeah,
So it can
because
be left like that, you think?
I think so. Yeah. The only thing I might do is multiply this 4 times the 5 and get
Okay.
20.
Oh, I see. Yeah, that's how they left it. He left it
Yeah.
at 20x squared minus 4.
Hmm.
So that would be, yeah. Okay. 20x 2 times 5 is not 20 though.
Well, no. What he just has this in the different order because he did these two first and then he did these two second.
Oh, that's so that's why his answer looks different. Okay. So
Hmm.
how oh, he's multiplying this 4 times this 5. I see. Minus 4.
So there are things that can be done to simplify this, but he's not requiring it if you look at his answer keys. So
Yeah.
according to his answer key, this is where we should stop. And I am very glad that that's where he's having us stop because this is where we've done the calculus and we have
Yeah,
taken a derivative, but you can get lost in the algebra after that, and
yeah.
he's not making us do that.
No, I'm proud of myself for getting that far.
Absolutely. Yeah, well that's as far as
That
you
was
you got.
improvement.
Yeah, how far you got was to the answer. So, yeah, you're there.
Okay. I just have to remember the rules
Mhm. That's it.
because I keep having to look back at my notes. Okay. I did from yesterday remember the u prime times v plus v prime
Mhm.
times u, which I hadn't had memorized before today. So
Mhm.
that's good.
Yeah, you're that's definitely improvement. Yeah.
Okay. Um, so okay, 20. Oh, I see. He multiplied the 5 times the 4 over here to get 20, and then he had 5x minus 1 to the 3. And then he just brought this 5x minus 1. I'm just trying to reorganize. It's okay. I'll do that later. I'll figure out how to reorganize that later. Okay. What else? Okay, tangent line equations. Um, I have no idea how to do that. That's part 6, which we haven't ventured into yet.
Do you want to start with maybe B? That looks like the
Yeah.
roughest.
Okay.
So, or actually, we've got time to do a couple, so we don't have to rush. We could start with A if you want to
I
do that.
also want to try critical points. Oh, well they're both about tangents.
Mm-hmm.
Find the equation of so this is find the equation of the tangent line to the curve at the point given.
So let's start with A, and then we're gonna do B.
Okay.
So with A, to take the derivative of this, because that's the first thing we're going to want to do when we're getting the slope of a tangent line, is to take the derivative.
Oh, okay.
Because derivative tells you what the slope is at any given point.
So I should write on the side, step 1, find the derivative.
Mm-hmm.
Okay. The derivative of this, f prime of x equals 4x cubed minus 2x. That
Mm-hmm.
wasn't that bad.
Nope. And this
Okay.
is at the point 0, comma 1. So what do we do with that?
Wait.
Or
Why do
1
we
comma 0. I'm sorry, 1 comma
why
0.
do we know that that's at 1 comma 0?
So read the
0 comma 1.
rest of the problem. It is supposed to be at 1 comma 0, right? So, yeah, 1 comma 0.
Um,
So it says A,
oh,
f
at
of
the
x
point.
equals, wait,
I didn't even see that. Okay. Um, at the point 1 comma 0. Okay. So what do we
so
so
recall that coordinates are x comma y.
okay. So we substitute 1 in for x.
Mm-hmm.
Oh, that's so cool. Okay, wait. Step 2, substitute. That's not that hard. Okay. Um, so when we substitute, we get 4 times 1 is 4. And then 1 cubed, which is just 1, right?
Mm-hmm.
Minus 2 times 1. So we get
Mm-hmm.
4 minus 2, which is 2.
Mm-hmm. Good.
So that was fairly straightforward. Is that
So
it?
far, so good.
Oh, now we
Well,
have to put it in slope intercept,
that's right. Yeah,
which is just the y equals mx plus b.
that'll work.
So we say y equals, ooh,
So which do we know and which do we not know?
we don't know b.
We don't know B,
Oh, yeah, we don't know b. Okay.
but we can replace Y with 0,
Okay.
and we can replace M with 2, and we can replace X with 1, and that's going to allow us to solve for B.
Oh, we need to find b.
Mm-hmm.
Okay. Um, I'm sorry. I'm very slow. Okay. Step 3. Put in slope intercept form and find b. Okay. So that gives us 0 equals 2 plus b. -2 equals b.
That's right. So now to complete our equation, we can replace M and B and leave Y and X as Y and X so that it's a general equation rather than the specific point of 1 comma 0. So the M we know is 2. The B we've discovered is -2. So Y
So,
equals 2X minus 2 is what we've got.
okay. That's not that bad.
Not that bad. Not that bad. And so when it comes to critical points, that's just one extra step. So as long as we're on this problem, let's do 7A as well,
Okay.
because there's only one little extra thing we've got to do for that. And that is to take the derivative and set it equal to 0. Instead of substituting points into it, we're going to take this derivative over here that was 4x cubed minus 2x, and we're going to set that equal to 0 and solve.
Um, wait. Oh, the when we were after we found the oh, after we found the derivative? Like when we
After
found
we found the derivative, yep. Set the
okay.
derivative equal to 0. Yep. So that's going to be 4x cubed minus 2x equals 0. What do we do first to solve for x?
Wait, 4x minus 2x equals 0. Um, do we factor out? Maybe?
We could factor out a 2 because they both have 2 in common. And we could factor out
Okay.
an x because they both have x in common.
So that's 2x and then times x. Oh. Oh, okay, wait. I'm really bad at factoring. Okay, 2x. Okay. Um, so we can we like separately like do 2x equals 0?
Mm-hmm.
Okay. 2x equals 0, and then divide each side by 2. X equals 0 over 2, which is 0.
Mm-hmm.
X equals 0. Okay. Um, I don't understand. Is that a critical point?
So that's a critical value.
That's a
X equals
critical
0
value.
is a critical value. Yeah.
Okay.
At critical values, that's where it can change from being increasing to decreasing,
Okay. Um,
or
okay.
decreasing to increasing. It's where it can change its direction.
Okay. I'm gonna really be hitting the books tomorrow. And just because once I feel like once we've done like one of each of these problems, I can just keep going and going and going.
I think that's true, but I think something that you may not realize is working in your favor is
Uh-huh.
that we've been going over this, not cramming all at once at the end, but we've been going through this for a while, working through, an hour a
Yeah.
day here and there. And so that makes a huge difference. Even if you're only spending an hour each day,
Yeah.
your brain is putting those puzzle pieces together.
Yeah.
And
So like if I put in an hour tomorrow and just try and review
mhm,
questions. Okay.
yeah. So I think you're in better shape than it might feel like.
Yeah. Well, math generally is just scary to me.
Hmm.
Um, just because it tends to one, give me anxiety, and two, like, blindside me. Like I'll like forget, like they'll like uh format it differently or like say something differently, and then like my
Hmm.
brain can't process the difference in wording, even though it's the same question.
Hmm. Well, and I think there's something about the way that we teach math that makes you feel bad if you get an answer wrong.
Yeah.
And that's not how it should feel. um, if you want people to learn stuff, you should like make it exciting for them to just keep practicing at it and practicing at it and practicing at it.
Yeah.
And it doesn't matter if they get it right or wrong. It should always be just okay, right?
Yeah, you should just get, as long as you show up and you try, you should get an A.
Well, or as long as you keep improving and practicing, it's more about
Right.
the improvement. It's more about the improvement
Right. So like let's
than
say
perfection on the first try.
yeah, you show up to class, you like are taking notes, and you're like showing up to the tests, and you're doing better, progressively better each test.
Hmm.
Then
Yeah, so they actually have an approach to that called mastery learning, which is where however long it takes you to progress to past a certain point, that's what it takes. So in other words, you get 100% on your all of your tests, and as long as it takes you to get there, fine,
I
right?
love
So
that.
yeah, yeah. Well, that's how I learn stuff. So like in my own private learning, um, there's no grades. Like I don't nobody's grading me. I just want to learn stuff. You know what I mean?
Right.
And so that's what I do is that I keep working on it until I understand that concept that I'm trying to
Yeah, well, that's
understand.
what I did today with the tangents.
Yeah.
The not the tangents, the limits.
Hmm.
Um, so I just have to do that for all the other.
Hmm. Yeah. Yeah. So the problem with um, the way that we teach it, I think it's just like ready or not, here the test comes, and
Right.
that's not cool.
No.
That's like, but that's how we do it. That's just how education is done. But I wish it wasn't like that, because it should really be like you keep practicing it until you understand it, and then once you understand it, okay, now you can move on to the next thing.
Yeah. Well, maybe you'll start
So
your school.
yeah, yeah, exactly. Once I redo the education system, I'll go ahead and do it, make it that way, right? So all right. So let's go ahead and keep working on 2x squared minus 1 equals 0. So we need to get x by itself.
Yeah. Okay, so we set just like we did with the 2x equals 0, we set 2x squared minus 1 equal to 0.
Mm-hmm.
Okay. Um, can we, I really don't know what to do, if I'm being completely honest. We can't,
We've
can we
got, go
factor
ahead.
it more?
We could factor it. We could factor it because so we could treat this as a difference of squares. Um, it could factor with a square root. So this could be factored as a square root of 2 times x plus 1 and the square root of 2 times x minus 1. This is called a difference of squares.
Well,
So
yeah,
if
well, that's what they have. So for their answer, his answer, he has
mhm,
0, 0,
mhm.
and plus or minus 1 over the square root of 2,
Mhm.
which is
So
what we're
then,
just,
right. So we're going to do that next where we set each one of these equal to 0 because we factored it. But I actually think there's an easier way to think about this,
I
which would
really
be,
hope so.
yeah, what I would do is I would add 1 to both sides. And so that would give me 2x squared equals a positive 1. So it's just going to be a positive 1 over on that other side there.
Okay.
And then I want to divide this by 2. So that's going to cancel out.
So we get x squared equals 1/2.
Mm-hmm.
Okay.
And then how do I get x by itself?
Um, take the square root.
Take the square root of each side. Absolutely.
So we get the square root of x squared equals the square root of 1/2. And to set that equal to 0.
Well, no, it's just the square root and the square cancel out. So I've solved for x now, and I just
Oh,
need to. I just have
I
1
didn't
over
even
square root of 2.
know that. Okay. So x equals the square root of 1 over 2.
Mm-hmm. And you can simplify the 1. The square root of 1 is just 1.
So my concern is that in the test, like I wouldn't know when to stop. Like, how do you know when to stop?
Well, I haven't yet because I would still rationalize this. I'd call it the square root of 2 over 2. And the other one is going to be the negative square root
Wait,
of 2 over 2. So it's
how did
plus or
you get the
minus.
square root of 2 over 2?
So this is called rationalizing, where I multiply the top and the bottom by the square root of 2.
Huh.
And 1 times the square root of 2 is square root of 2. And then square root of 2 times square root of 2 is the square root of 4.
Okay, wait. So you have the square root of 1 over the square root of 2.
Mm-hmm.
Okay. Well, x equals the square root of 1 over the square root of 2. And then you said you're gonna, I need a different color for this.
Okay.
Multiply it by the square root of 2 over the square root of 2. There's just so many tricks that you bring up, or like things that you bring up that I'm like, that's when it starts to scare me, because not that like you're scaring me, but like that the fact that there's so many little things that like,
Yeah. So I don't think he would take off if you left it as plus or minus the square root of 1/2.
so how would
Um,
I know that it was plus or minus the square root of 1/2?
so because when we take a square root at this point, actually, I should have put in plus or minus, and the reason for that, let's push this off to the side for a second. So if I had x squared equals just 1, let's take roots and all that kind of craziness out. So just x squared equals 1. What values would make that true?
If x were 1.
If x were 1, 1 times 1 is 1. What about if
Right.
x, what about a negative 1?
-1 times 1 is -1. Oh, but -1
Squared times
squared is
itself,
-1 times a -1, which is 1. Yeah.
which is 1. So that
I get
means
it.
that x could be equal to plus or minus 1 because it's both.
Okay. That makes sense. So whenever I have the square root of something that
Hmm.
looks like this, it's plus or
Yes. whenever you have something squared and to get rid of that square, you're taking a square root. Yes, you do have to do a plus or minus.
Okay. Okay. And why, okay, what is this whole rationalizing thing?
So rationalizing is done because we don't usually like to have square roots in the denominator.
Okay.
But that's really just more of a matter of taste.
Okay.
It's not a like it's wrong if you don't do this kind of thing, or at least in my book, it's not.
So
I would. Hmm?
sorry, you think that he would accept the square root of uh or the square root of 1/2, like plus or minus the square root of 1/2.
I'm only showing you this in case it's multiple choice or
Yeah,
anything on there is
it's
multiple
not.
choice. There's
Somebody
none of
asked
that.
today,
Okay.
one of the kids goes, what percentage of questions are multiple choice and what percentage of questions are free response? And he goes, it's a mix of 0% free multiple choice and 100% free response.
Okay, good. So he'll
Funny,
probably
funny.
yeah, he'll probably be happy with this.
Okay.
I would be surprised if he marked you wrong for that.
Okay, so then how do we, okay, calm. Okay, so we dealt with the 2x squared minus 1 and we dealt with the 2x. So where is he getting this comma -1/4?
So his let's look at that question. Okay, so this says find the critical points. I gave you the critical values, and now we have to find critical points. So in order to be a critical point, it needs an x and a y value.
Wait, so 0
Zero
is
is one. Yep.
plus or minus the square root of 1/2
Mm-hmm.
are my critical values.
And he's leaving it as so the square root of 1/2. The only part of that he's simplifying is he's saying that this is equal to 1 over the square root of 2, because you can break this up into the square root of 1 over the square root of 2. Like you can separate fractions
Yeah.
like this, and then what is the square root of 1? That's just 1.
Ah,
And so because that's in his answer key, that is indeed how he wants you to leave it. So that's perfectly fine.
okay. And he does that because you don't want fractions in the numerator?
You mean why does he go from
Yeah, like
here to
why does he
here?
feel the need to do that?
Well, which looks better to you? Square root of 1 or just 1?
Just one.
So simplify it.
I'll write reasoning because simplification.
Mm-hmm.
Okay. I'm trying to be very in-depth with my notes because
Mm-hmm.
when I go back to try and do this again tomorrow, it
Mm-hmm.
needs to be stupidly clear.
Okay.
Okay. So we've now at this point found our critical values.
Mm-hmm.
So how are we going to use those critical values to find this -1/4? And why is it the answer 0, 0, 0? And I'm a
Well,
little here.
yeah, sure. Let's find out. So whenever you have an x value, to get the y value, where do you plug it?
Um,
Excuse me.
into the, oh, sorry, into the original equation.
Into the original equation.
Okay.
Exactly. That's what functions are for. So this
Wait,
f of
so
x.
okay, we found our x value.
Mm-hmm.
Our x equals 0. So we're going to plug the 0 into this. Okay. Plug 0 into here. Original. Okay. Um, I should use a different color. Okay. Green. You're using green. That looks good. Um, 0 to the 4 minus 0 to the 2, which is just 0.
It
So
is
why
0. Mhm.
equals 0.
That's right. So that's where we get our point. Um, that's where we get our 0.00.
Okay. So, okay. Oh, this is not like actually hard. It's just the processing of it.
Mm-hmm.
So the 0.00 is one of our critical points.
Right. So 0, 0 is a critical point. And then we're going to do the same thing with 1 over, or square root of 1 over 2. You could even leave it as square root of 1 over 2
So whenever we
because,
find, so now I'm starting to understand. I'm sorry to interrupt you. So when we find one of our critical points, or
Mhm.
however many critical points we end up having, we have to plug each one of those into the original equation, and that's how we get our once we find each of our critical values, we have to plug each of those critical values in to the original equation, and that's what gives us our critical points.
You are 100% correct.
Oh, that makes so much sense. Okay. So I have to plug. Also plug plus or minus 1 over the square root of 2 into original. Okay, I'm having a little bit of a um hallelujah moment.
All right.
Okay, so f of x equals the, okay, 1 over square root of 2. Oh, it's plus or minus though, or it doesn't matter.
It is. I'm just making sure that I get the same thing he gets. And
Okay.
yeah, so it'll come out to -1/4 if you do this with a positive square root 1 over 2. And you'll also get exactly the same thing if you substitute in a negative square root 1 over 2. So either way, plus or minus, it ends up giving you -1/4 as the result. So there's actually 3 points there, but he's listing it with only 2 parentheses because he's using a plus or minus.
Okay.
So another way to write that would be 0, 0, and then square root of 1 over 2, comma, -1/4, comma, and then a negative square root of 1 over 2, comma, -1/4.
So the point plus or minus 1 over square root of 2 -1 over is second. My notes look crazy. Okay. So you're saying that I see. So what's the difference between like writing -1 over 4 like he wrote it versus the negative sign in front of the 1 over 4? Like why does he
Oh,
very
there is there is no difference. Yeah.
Okay,
So
so
I
you
did.
think he would accept it if I put -1/4?
Yeah, I didn't even notice that he had put the negative in the top, but it doesn't make any difference because -1 over 4 is the same thing as a -1 divided by a +4, which is
Okay.
also the same thing as a 1 divided by a -4. But
What?
this way, yeah, because a positive divided by a negative is the same as a negative divided by a positive, which is a negative result. Forget about fractions for a second. Okay, forget about fractions for a second. If I have a negative, so let me scoot all this out of the way. So if I have, let's say, a -2 times a +3, what is that?
-6.
A -6. And if I have a +2 times a -3,
It's still -6.
it's still -6.
Yeah,
And if I have a -2 times 3,
it's still, you'd have, okay.
it's still -6.
Yeah.
So it's the same thing with division. If you have a negative out front, that's like having the negative out front here.
Okay.
If you have a negative in the numerator and a positive in the denominator, the result is negative. If you have a positive in the numerator and a negative in the denominator, the result is negative, because if it's one of each, the result is negative.
Yeah, I see.
So any of those is correct. However, it is not customary to write it like this: 1 over -4. It's true, but it's just not classy.
It's not normal.
Yeah, yeah. So we don't like to have the negatives on the bottom. It's kind of confusing that way.
Yeah. Okay.
So let's do we have are you feeling pretty good about that one?
Yeah.
Okay.
I'm gonna practice it, but
I mean, there was a lot to it. We started way up here. This was the
I know.
original, and then we
Well, because
got
we were being
all
very
this.
thorough about like the steps, and
We were. Yep.
you could probably
Um,
shorthand it once you get better at it.
oh yeah, yeah. This won't take you 30 minutes to do once you've practiced it a bit.
Yeah.
So but let's do one more from that section, and
Okay.
we can finish up, I think, with part B, if that sounds good to you.
Yeah.
So let's
From
do that.
section 7, the critical points.
Yeah, 6 and 7.
Yeah.
So I'll do 6 and I'll do 7 for that,
Oh, okay, cool.
because it's the same equation, so we'll already have the derivative and everything.
6, B.
6b. Yep.
Okay.
So this is going to be g of x.
Wait. Oh, I'm looking at the answers, not the equation.
Mm-hmm.
G of x equals -2 over x squared at x equals 2. Okay. So step 1, find the derivative, right?
Mm-hmm.
And this is quotient, which
Yes, you could do
here,
the quotient. It's possible to do it with the quotient, but
okay,
it's not necessary to do it with the quotient.
okay, let's not then. Is it easier to not?
It's easier to not. Yes.
Let's not do that then.
Yeah. So, but why can we get away with not doing it in this case? Any ideas?
Substitute the 2 for x.
Well, you remember how I said it's something over something
Yeah.
with the quotient? And but that something on the top, notice how it's a constant. So when you have a constant on the top, there's no variables, nothing's changing on the top. Because remember
Uh-huh.
that when you're taking a derivative, that's examining change, and nothing's changing on the numerator.
Right.
So what you can do is you can actually bring this up and rewrite this as g of x is equal to -2 x to the -2.
G of x, okay, is equal to -2x negative 2. Oh, I see. To the -2. Okay.
Because when
I
it's a
thought,
negative, it's in the wrong place, but we could, or you could think of toggling, right? So it's like a light
Right.
switch where to bring it up to the top, switches it negative.
Okay. So now we can plug the 2 in.
Well, not yet. First, we
Yeah.
have to take the derivative. Now we can take the
Oh,
derivative.
okay. So now we have negative, wait, no, negative times a negative is a positive. So, okay, g prime of x equals 4x. Okay, I have to do that on the side. Negative 2 over 1. Wait, minus 1, right? Minus 1 over 1.
So what we're doing is
We're
subtracting.
subtracting 1 from
Mhm.
the negative 2 is what's happening. Okay, so negative 2 over 1 minus 1 over 1 equals negative 2 minus 1. I don't know why I can't process this right now. Negative 2 minus 1 is negative 3 over 1, which is negative 3.
It is -3. We didn't have to use fractions for this because neither one of those had a fraction.
Right.
So you could just do a regular old negative
I don't
2
know
minus
why I don't know why I couldn't do that.
because you're so used to using fractions. You've
Yeah.
had to do fractions for a
Which is
lot
so
of years.
weird because now I'm like I used to be so terrified of fractions and now they're helping me.
Now you're just so used to it. Yeah, it's okay.
Okay. So that's the derivative. So now we can plug the 2 in, right?
Now we can plug the two.
Okay.
Exactly.
Um, so that is sorry, 4 times 2. 4 times 2 to the negative 3. I have to do that on my calculator.
Well, that's just 1 over 2 to the third. And what is 2 to the third?
Wait, why?
So okay, let me back up.
Wait, why can't I just do 4 times 2 to the negative 3?
You can,
Okay.
but
That's just where my mind goes.
so that comes down to but it's hard to process that without a calculator. So you bring this down to the bottom and you got 4 over 2 to the third. Because if it's negative, you could bring it to the bottom and make it positive.
Okay, wait. So you're saying that I probably couldn't do that with like do what I wanted to just do with the TI 30 XII or
I'm not saying you couldn't do it with a calculator. I'm saying you wouldn't need a calculator
hmm,
because that's just 4 over what's 2 to the third? 2 times 2 is 4.
okay.
4 times 2 is 8. So it's just 1/2.
Okay, but I'm confused about why we went to division.
Because we had a negative in the exponent. And
Oh,
to get
okay.
to get the negative out of the exponent, you move it down to the denominator.
Okay. Okay. Equal okay. Which equals 4 over 2 to 3, which equals 4 over 8, which equals 1/2. Okay, got it. So now,
So that was our m.
okay.
That was our slope at that point.
So now we have to put it in slope intercept form. So let me just write y equals mx plus b.
Mm-hmm.
So we have our m. This right here is my m. So far we have y equals 1/2 x plus b.
And I think he gave us a point.
Yes. He, oh wait,
It just said at x equals 2. So he didn't give
yeah,
us the y value for that.
no. So we have to find y.
Mm-hmm.
So we substitute this 1/2. No, what do we do?
So
Oh,
we know that x is equal to 2, and we can substitute that into the original function to get the y value.
okay, wait. G of 2 equals negative 2 over 2. Wait, how did we get 2? Oh, from the thing. Okay. Over 2 squared, which equals -2/4, which equals, is that -1/2?
All
Yeah.
right, so that's going to be our y value.
Okay, so now we have -1/2 equals +1/2 plus b.
Good.
So now we need b.
We do need b.
So now we would say -1/2 -1/2 equals b. So that's negative -2/2, which is just -1.
I think you're missing a
No.
little bit here because so it was m was 1/2, right? And then x was 2. I think you might have forgot that x is 2.
Oh, wait, so then, okay, I'm sorry. I know we're going over time. I'm confused about the one, why do we have, what was the use of the +1/2 then? Like, why did we do all of this work in the beginning
So
when
that
we
is
told us what
that
x was?
right. That is m. M is 1/2.
Oh, okay. Now I understand. Okay. And this is our x. Oh, okay. I get it. I get it. I get it. Okay. So now we have -1/2 equals 1/2 times 2 plus b. Got it. Okay. I was forgetting about the 2, and now I see where it goes, and I understand why we have the half. Okay. Got it. Okay. So then we want to, should we multiply the 2/1 by the 1/2 first before we bring it over?
Sure. And
Okay.
well, or actually, so I did divide
That's
that.
that's just 1.
I did divide it as just 1, but then I brought it back as 2/2 because I need to combine it with a -1/2.
Oh,
So I didn't notice that, but you're right. We actually could have just left it as 2/2 and subtracted that to the other side
okay.
as 2/2. So
So -1/2 equals 2/2 plus p. Okay. So the -1/2 minus 2/2 equals b. So -3/2
mhm,
is b.
that's right.
Okay. So our equation, now that we have all the players of the game,
We do.
or characters, or whatever we want to say, is oh, we put it back in the original because we don't want, we want it to be y equals something plus something, not
Hmm.
something equals something plus something. That sounded really bad. Okay, y equals um 1/2 x plus x minus 3/2.
That's what I get too.
Okay, and that's what they have. Okay, that's not that bad. That's really not that hard. It's just a process and remembering what you're doing.
Absolutely. Absolutely. So, and the next one is actually 7b is actually really short
Okay.
because when we take the derivative of this and we set that equal to 0, so I'm going to take this derivative, which was 4x to the -3rd,
Okay.
right? So
Wait.
this
7b
was
is g of x equals -2 over. Do you think on the quiz or the test he's gonna have it like a series like this where he like has us work it out and then has a part two to it?
Probably. Yeah,
I
I
think
would.
that would be most logical.
I think he will. Yeah,
Okay.
because he's having you do multiple things with it here, so he'll probably do that again. So we're going to take this derivative, and what we're going to do is set this derivative equal to 0. So I'm going to say 4x.
So we've already figured out g prime of x equals 4x to the 3 or to the -3. Okay.
4x to -3 equals 0. So that's where I'm at now. And I'm
Okay.
going to bring this down so that it's easier for me to conceptualize. So I'm going to convert this from being a negative exponent into being a fraction. So this is going to be
Okay.
4. So this is going to be 4 over x cubed
Um,
is equal to 0.
okay. 4x over 1 to the -3 equals 0. Okay. And then you bring that down. 4 over x to 3 equals 0. Okay.
So the only thing that would make this true is if x were infinity. And infinity is not a value that we could actually substitute in there. Because remember how we said that a constant divided by infinity is equal to 0?
Right.
But nothing else will ever equal 0. It might be close. Like you could pick an x value that's big and it would potentially get kind of close to it. But you'll see that when we multiply both sides of the equation by x cubed to clear that fraction,
Yeah.
so we'll go ahead and we'll multiply both sides of the equation by x cubed. It cancels out here, it cancels out here, and I get 4 equals, what is 0 times anything?
0.
0. The only exception to that is infinity, which is indeterminate. 0 times infinity is indeterminate. But 0 times anything else, 0 wins. So it's going to be 0. So now we have the equation 4 equals 0. That's
Which is
false.
okay.
Yeah,
So that's why he's saying the tangent line is never horizontal.
that's right. There is no place where it is horizontal.
Okay. Okay, cool.
All right, so I'll leave you with that, and actually, I'll upload this, and I'll try to publish it tonight, so that in case you want to refer back to this, you can.
Thank you.
Yeah, you're welcome. Yeah, I'll have to send you the link for it too.
Oh, thank you, Jesse.
You're welcome. I'll see you next time, Carly. Good
Okay.
luck.
Bye.
Bye bye.